Problem 5, multiplying conjugates. Remember, a conjugate means the same numbers, different middle sign. Let's FOIL. And it's really not foiling, the real word is multiplying your binomials. But anyway, let's FOIL. 5 times 5 is 25. 5 times the square root of 7 is 5 square roots of 7. Negative 1 is minus 5 square roots of 7 when you multiply. And this is minus the square root of 49, because 7 times 7 is 49. You know this is really just minus 7 though. Now watch what happens. This here was a conjugate, because it was the exact same thing with different middle signs. Watch what happens to the middle terms. They're plus and minus of each other, so they just cancel each other out, and you're left with 25 minus 7. Final answer, 18. So a conjugate, let's make a rule here. A conjugate gets rid of the square root. Just like you used to learn that a conjugate got rid of an imaginary number, a conjugate also gets rid of a square root. Problem 5. 6 times 6 is 36. 6 times the square root of 12 is positive 6 square roots of 12. By the way, that would reduce. You would have to reduce that if it doesn't cancel. Minus 6 square roots of 12, because of the negative sign, minus the square root of 144, because 12 times 12. You know this is really just minus 12. Look what happens to the middle terms. They cancel out in a conjugate, and you get 36 minus 12 is 24. Let's try this conjugate thing one more time. 3 times 3 is 9. 3 times negative square roots of 8 is negative 3 square roots of 8. Square root of 8 times 3 is plus 3 square roots of 8. Notice how you just put the number in the front. And last, square root of 8 times the square root of 8, this is minus 64, the square root of 64. Which you know, minus square root of 64 is really just minus 8. Look what happens to the middle terms. So you get 9 minus 8 is 1. Again, the conjugate helps you to remove the square root. Problem 6, rationalizing your denominator. We learned this rule not too long ago. You cannot leave a square root or a cube root or any type of roots in the denominator. So look at problem 6. I don't care what the top looks like, I only care about the bottom. You're going to multiply by, well, what got rid of the square root? Let's rewind. What got rid of a square root? A conjugate. So in problem 6, we're going to multiply by the conjugate. So we'll multiply by the square root of 5 plus the square root of 2. Square root of 5 plus the square root of 2. This is no different than when we did it with imaginary numbers. The top will need to be distributed. The bottom will need to be multiplied out. Alright, be careful with this top. You ready? Put a 1 in front of these if you need to. 3 square roots of 2 times the square root of 5. Remember, inside with inside, outside with outside. 3 times 1 is 3. Well, that leaves me with the square root of 2 times 5 is 10. Then we're going to do 3 square roots of 2 times the square root of 2. That's 3 square roots of 4. We'll deal with this in a second. Put a star by it because you know what the square root of 4 is. And on the bottom, square root of 5 times the square root of 5 is the square root of 25. Inside with inside. Square root of 5 times the square root of 2 is plus square roots of 10. Negative square root of 2 and square root of 5 is negative square roots of 10. Negative square roots of 2 and positive square roots of 2 is minus square roots of 4. Now let's go ahead and fix this. Make it look a little better. You know, right here, this is really just 3 times 2, right? So you should know your top becomes 3 square roots of 10 plus 6. The bottom Look what cancels out. And you know the square root of 25 is 5. You know the square root of 4 is 2, in this case a minus 2. So you get 5 minus 2 is a 3. Just like we did with imaginary numbers, you can reduce all the outside numbers by a factor of 3. So let's rewrite that you get the square root of 10 plus 2, or if you want to rewrite it, 2 plus the square root of 10. I really don't care which way you write it, as long as you get it right. That's all that matters to me. Let's try the got it. Be careful with this one, same type of idea. Use your conjugate. So we'll multiply by square root of 3 plus the square root of 5. And down here we'll multiply by the same thing. The top will need distributed. Be careful, the top might need to be multiplied just as difficultly as the bottom. Okay, distribute the top. This becomes 2 square roots of 7 times the square root of 3 is 2 square roots of 21. Inside times inside, outside times outside. This becomes 2 square roots of 35. Inside times inside, out times outside. Square root of 3 times the square root of 3 is the square root of 9. Square root of 3 times the square root of 5 is the square root of 15. Square root of 5 times the square root of 3, this is a minus square root of 15. Square root of 5, square root of 5, this is a minus square root of 25. Now ask yourself, is there any perfect square in 21? No. That one's done, give it a check mark. Is there any perfect square in 35? No. That one's done, give it a check mark. Let's look at the bottom. The square root of 9 is 3. The square root of 25, this is a minus 5. The middle things cancel out, and the top remains the same. Let's carry the top over. To carry the top over, you get 2 square roots of 21 plus 2 square roots of 35, all over on the bottom. 3 minus 5 is a negative 2. Remember, you cannot keep a negative in the denominator. You'll never find a reduced answer that way. So we're going to, number 1, we're going to divide by 2, and number 2, we're going to distribute through the negative. Okay, so we reduce everything by 2, and I divide by the negative. So negative square root of 21 minus square root of 35 is the final answer. Part B. Use your conjugate again. Multiply by 3 plus the square root of 6 over 3 plus the square root of 6. The top will need distributed. The bottom will multiply the binomials. 4x times 3 is 12x. 4x times the square root of 6 is plus 4x square roots of 6. All over. 3 times 3 is 9. No square root on that one at all. And then 3 times square root of 6 is plus 3 square roots of 6. The middle is minus 3 square roots of 6. And the end is minus the square root of 36. Look at the top. Neither one of these needs fixed, so we can just carry it over. And this is all over. Let's go ahead and reduce the bottom. You know that this turns into a minus 6, so 9 minus 6 is 3. Don't forget to cancel, which you cannot do. So don't cancel. Nothing reduces all together. Okay, you either have to reduce all the insides and all the outsides, but since 4 doesn't divide by 3, we are done with this answer. Just so you know, if you looked in the back of the book, you would see this. Okay, they're going to put the 1/3 out in front. I actually think Miss Miles and I, so when you have her in the future, I think we prefer this, although this is an option. Part C, let's look it over. Suppose you were going to rationalize the denominator of this by multiplying by the square root of 8 before would you simplify the square root of 8 before rationalizing? I'm going to say yes or no is a good answer. It depends. If you simplify first, it's easier at the end. Whereas you simplify last, it's easier at the beginning. Now what do they mean by simplifying the square root? They're saying if you make the square root of 8 2 square roots of 2. That's what they're asking you about. They're saying, would you simplify the square root of 8 to be 2 square roots of 2? Well, maybe at the beginning, maybe at the end. I like to do it at the beginning because that's the way I was taught, but it doesn't make a difference as long as you're right. Now that's it for the lesson. I will suggest to you to try a couple of these, especially number 4. I'm noticing that there might be a trick on number 4 that a lot of people don't take. And also problems like 6 and 7 to make sure you really understand the concept of inside times inside and outside times outside.